Today we're going to look at lesson 2.5, which is solving equations, but we're involving absolute value. If you remember, absolute value is basically the distance between a number and 0 on the number line. So you can have a distance of 4 units for the number -4, but you can also have a distance of 4 units for the number +4 if you're thinking about a number line. So absolute value is considered always positive because it's measuring distance, not telling me a number. So if we keep that in mind, when we're solving or we're evaluating anything with absolute value is going to actually be your last step to think about. So in this case, we would plug in x equals 2 first. And notice these straight up and down lines. These lines are called the absolute value. So if I'm going to plug in 2 for x, I'm going to replace the x with the 2. I'm going to use the absolute value symbols to direct me to do what's inside the absolute value first, kind of like parentheses. So 3 minus 8, which is -5. Because 4 times 2 is 8, so 3 minus 8 is -5. Now I have 23 minus the absolute value of -5. And if you think about how far -5 is from 0 on a number line, that would be 5 units. So the absolute value of -5 is going to be 5. So I would do 23 minus 5. And that would give me 18. Now we're going to solve the equation involving absolute value and graph our answer on a number line. So to solve, when you have absolute value, since you have two cases usually, you have the positive side of the number line and the negative side of the number line, you're going to have two answers almost all of the time. So to set up your answers, you would have two cases. You'd have y plus 2 equals 4, which is the exact same thing as the equation given, except for I've taken the absolute value symbols away because I've taken the absolute value by giving two cases. So y plus 2 equals 4, and y plus 2 equals -4. So we have the two scenarios that will be on our number line. I'm going to solve each separately to get y equals 2. And y equals -6. So my two answers would be 2 and -6. If I were to graph them, I would need to put my numbers on a graph or a number line. By using just a dot. So I'm going to put a dot at -6, and I'm going to put a dot at 2 to indicate my two answers. Okay. Now we're going to solve this one. Again, we have two scenarios, but what you need to think about is absolute value is never negative. So if it's equal to a negative number, that would make no sense. So look at here. We have an absolute value equal to a negative number. So in this case, this is actually going to be no solution. Now, the next problem, we're given a word problem. When we're speaking of absolute value in real-world situations, a lot of times you might see them saying maximum and minimum, or an allowance, or they might call it margin of error, or plus or minus. Basically, it's a range of values when you're thinking of absolute value because, like I just said, you're always going to have two answers. You're going to have the positive version and the negative version. Doesn't necessarily mean the numbers are going to be positive and negative, but you need to have both scenarios considered. So, in this case, we have ice cream should be stored at 5 degrees with an allowance for 5 degrees. So, an allowance for 5 degrees, that is what's telling us what our absolute value equation is going to be set up with. It is always x minus a given value. This is how you would set up an absolute value equation with that in absolute value symbols. And then it's going to be equal to the absolute value. So they call this either margin of error, or they have minimum and maximum. And these are keywords. Then you have an allowance, like the problem we're on says. All of these mean something is related to absolute value. So you'd put those numbers in here. Okay, so back to the equation. If I am storing it at 5 degrees, that's going to be my given value. That's what I know. Then it says an allowance for 5 degrees. That 5 is going to go into what it's equal to, because that's where we put the absolute value numbers. So to find the minimum and maximum temperatures, I'm going to plug in 5 for the given value. And in this case, and this is not always the case, it's also going to be equal to 5, but that's because they were talking about the allowance of 5 degrees, not that it's a given value. So sometimes, most of the time, these numbers are going to be different. So x minus 5 equals 5. To solve, I would need to do my two cases like I did for the last example, where I have x minus 5 equals 5, the positive version, and x minus 5 equals negative 5. So I'm going to solve those, and x would be 10, and then in this case, negative 5 plus 5, x would have to be 0. So my two temperatures, or my minimum and my maximum temperature that I could store the ice cream at, would have to be 10 degrees or 0 degrees. Now, my final example is to write an equation involving absolute value, and your answer has to be 17 and 27. So if you think about getting or setting up your equation, it's always going to be x minus something when you're setting up an absolute value equation equals something else. So think about how could you get one of these values. You're going to have to try and get the higher value first. So the example they have is, let's say you have x minus 22 equals 5. When I bring the 22 over and add it to the 5, I'm going to get 27, which is one of my answers. Now, if I were to keep it like this and do absolute value solving, I would get x minus 22 equals 5, x minus 22 equals negative 5. So when I add 22 to 5, I get 27. And when I add 22 to negative 5, I get 17, which is my two answers that I need to have. So the equation is going to be x minus 22 equals 5. And really, you can use any two numbers here as long as you're getting the higher value as your first answer, which would be 27. Okay, so that is the end of Lesson 2.5.